Okay, so this is going to be a continuation. This one talks about what's called compound interest. Basically what happens is a bank will take your money and they will give you interest on how much you originally put in the bank. That's called simple interest. But if the bank gives you interest not only on what you put into the bank, but also on the interest you're getting back, then it's called compound. Okay? So here's what we do. A represents the balance that's in the account, how much money you have. P stands for the principal. That's the initial amount that you put into the bank, how much you start with. R represents the rate, the interest rate. We write it as a decimal. N represents the number of times it's compounded every year. So you'll hear things like quarterly. That's 4 times a year. You'll hear biannually. That's twice a year. Maybe you'll see monthly. That's 12 times a year. Okay? So the words that are provided in the question will tell you what N is. And T is the amount of time that you keep it in the bank in years. Okay? So suppose that when your friend was born, your friend's parents deposited $2,000 in an account paying 4.5% interest compounded quarterly. Okay? What will be the account balance after 18 years? So look, here's everything we need. This 2,000 is P. This R is the rate. Okay. This quarterly means N is equal to 4. And this represents T being equal to 18. So all we have to do is go through and plug it in. So A is equal to 2,000 times 1 plus, and then R, 0.045 over N, and then multiply N and T. Okay? So we have P, the amount that we started with, R, the rate at which it's growing, N, the number of times that it's being compounded, N, the number of times it's being compounded, and T, the amount of time that it stays in the bank. Alright, so I would suggest you pause and you plug this in. Okay, you work on this part first and then take it to the power of 72 and then multiply that whole thing by 2,000. And what we end up with is going to be the amount of money in the bank that your friend did absolutely nothing for. Okay? So that's a good thing. The answer should be $4,475.53. That's how much money ends up being in the bank when it starts with 2,000 and 18 years later she takes it out. Right? Now this one uses some of the same information, but now it says compounded monthly. Okay? We're still looking for it after 18 years, so we're still going to set up the same way. P times 1 plus the same rate, 0.045. This time it's over 12. Taken to the 12 times 18. Okay, so probably going to be a bigger number, we'd have to assume. Okay, so we put this one through the ringer, we get 216. We do all this stuff, we take it to the power of 216, and then we multiply by 2,000. And what we end up getting, believe it or not, is $22,411.63. Now, you're not going to find anything compounded monthly. It's just not going to happen. So that's why it grows so fast. You go from $2,000 to $22,000. It's a fairy tale. Okay, decay. Now notice, if you remember, A was greater than 0 and B was greater than 0. But now B is going to be between 0 and 1. Okay, can be modeled by the function the same thing, The base b is now the decay factor, which equals 1 minus the percent rate. Okay? So a is still the initial, b is now the decay factor, which is going to be 1 minus the percentage, and then we're still going to have an exponent right there. Okay. All right, the kilopascal is a unit of measure for atmospheric pressure. The atmospheric pressure at sea level is about 101. Okay. For every 1,000 meter increase in altitude, the pressure goes down this much. So this 101 kilopascals is A. It's the starting point. It's what happens at sea level. This is the decay. Okay. It's going down by that much. We want to find out what's it going to be at 3,000 meters. Okay. All right. So A is the initial pressure. That's 101. B is the decay, which is 1 minus the percentage. So we get 0.885. So we plug it in. Okay. Now, we've made X to be the altitude in thousands of meters. That means we don't have to plug in 3,000. That means we can simply plug in 3. Okay. So that one's a pretty helpful thing to be able to do. So we do 0.885 to the power of 3 and then multiply by 101, and what we end up with something close to 70 kilopascals. Okay. So this is A, the initial amount, and this is found by taking 1 minus the percent of decay. Okay. All right, so the next question says, what is the atmospheric pressure at an altitude of 500 meters? So we still have the same thing. Y is equal to 101 times 0.885, except this time we're doing it to the power of 5. Okay. So that's going to give us a slightly different answer. All right, so after doing this, 0.885 to the power of 5 and then multiplying it by 101, we should end up with about 55 kilopascals. Okay. So at 5,000 meters, we went from 101 to 55. It makes sense because for 3,000 meters, we went to 70. Okay, and why do you subtract? Because it's a decay. It's eroding, it's going away. That's why we saw the negative slope of that line. Okay, so this is decay. It's different from growth. Growth, remember, we're taking 1 plus the rate, and for decay, we're taking 1 minus the rate. Okay. Formulas are the same. It's just this will change based on its situation. And then remember, we have the other formula. Okay, so for the compound interest, we've got P, which is the principal, the starting amount, 1 plus R over N to the power of N times T. Okay, R is the rate, N is how many times it's compounded, T is the amount of time in years. Okay. So same formula for growth and decay, slightly different formula for compound interest. Practice, 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 ask questions. That's the end of the video.